Hello there. Hello, doctor. My name is Yusuf Shalafi. Thank you for giving me this opportunity to explain my presentation today. And now I'm going to introduce myself first. I am Yusuf Shalafi, and my student ID is AIT2502193. So let me describe my presentation. This presentation today in the course Calculus 1 under the Dr. Altaf. And today I'm going to explain about the applications of derivatives in economics and also the intermediate value theorem. So let's move to, first of all, we are going to begin with what is the calculus? What is this science? So calculus is the branch of mathematics that studies change. How? It allows us to measure how fast things are changing and how quantities accumulate. So it is widely used in science, engineering, economics, and even artificial intelligence, which is, by the way, my major. So there are two main branches of calculus. First, differentiations, which is measures how something changes. So, for example, speed of bodies or items. And the second one, which is integration, which is add up quantities, for example, area under the curve, or many examples that we are going to show today, inshallah. So why is calculus important? Calculus plays an important role in many fields. So let's take some examples about where we can use calculus in our life and also in science. So first, field. So we use in fields application and also in physics, for example, motion and energy, and also in economics. So we know the cost, the profit, and the revenue. This is also, we are going to explain more about it today. And also we can use it in engineering, for example, design and mechanics and so on. And also we can use it in AI and machine learning, for example, model optimization and training, and also medicine, for example, drug dosage, and so on of science that we can use calculus in. So that is why calculus is important in our life. So when we move to the first topic, which we are going to explain today, which is applications of derivatives in economics. So derivatives helps us understand how economic quantities change, especially when we are taking the average revenue, so the revenue of per unit sold, and also the marginal revenue, which is the additional revenue from selling one more unit, for example. So we have two formulas. The first one, which is the average revenue, which is equal the total revenue over quantity. So this is for per one unit. And also the marginal revenue, which is the differentiation of total revenue over the differentiation of quantity. This is when we add one more unit. So let's take our first example. Let's say a company sells 5 products for 10 ringgit for each unit. So the total revenue going to be 50 ringgit. And the AR, which is the average revenue, going to be 50 over 5, going to be 10, which means on average, a company earn 10 ringgit for each product. Now the company sells the 6th unit for just 9 ringgit. That means they earned less on the new unit than before. So the new total revenue is going to be 50 plus 9 is equal 59. So the marginal revenue is additional revenue from selling one more unit, which is 59 minus 50, going to be 9. So MR, which is the marginal revenue, is less than AR, which is the average revenue. So this is usually happens when a company has to lower the price to sell more products. So when we move to the next example, we see that the total revenue with quantity. So for example, we take 100 quantity minus 2 quantity over 2. And the marginal revenue going to be the differentiation of the total revenue over the differentiation of quantity. So it's going to be equal 100 minus 4Q, K, which is quantity. And we see here that the quantity increasing while the marginal revenue is decreasing. This means that the marginal revenue decreasing as the company produces and sells more. And when we see the example number 3, in monopoly companies or markets, one company, for example, controls the market to sell more product. So the company needs to lower the price to sell more. So when they lower the price, they don't just apply it to the new unit. They have to lower the price for all units sold. So when selling an extra unit, the marginal revenue going to be less than the average revenue, because the drop of the price reduce the revenue for all items. So that's why in monopolies, the marginal revenue always less than the average revenue. So this is all about the applications of derivatives in economics. We take 3 examples to explain about the topic. So next, we are going to take the second topic, which is intermediate value theorem. So this is an important concept in calculus, especially for finding roots of equations. And the theorem says if a function is continuous on the interval a and b, and the function of a and the function of b have opposite signs, then there exists a value of c between a and b such that the function of c is equal to 0. In simple words, it means the function must cross the x-axis between a and b. And now let's take some examples about this theorem. We have a function given here, which is f of x, x power of 3 plus x minus 1. So when we plug in x equal 0, because we given 0 and 1. So we plug in first when x equals 0. So we get the answer is equal minus 1. So it is a negative number. And when we plug x as number 1, we get the answer is equal 1. So it is a positive number. So the function changes the sign between x when x equal 0 and when x equal 1. So that means it goes from negative to positive. The intermediate value theorem says that if a continuous function changes the sign from negative to positive or the opposite, so it must cross the x-axis somewhere in between. So there exists a value c, which is a constant, between 0 and 1, such that of this constant is equal 0. And example number 2, which is a sine function. So this time we use a sine function, which is of x equal sine x. And we look at it between x equal 3 and x equal 4, because we're given these two numbers. So when we plug in, we see when x equal 3, we get a positive solution. And when x equal 4, we get a negative solution. So since the value have opposite signs, so the function cross the x-axis in that interval. So because sign is continuous, because the sign is continuous, we can say that there is some number c between 3 and 4 where sign of this constant of this c equals 0. So let's see the example number 3, which is a coordinate function. So the function is x power of 2 minus 4. This is a simple quadrate function. So when we plug in x as number 1, so we get a negative solution, which is minus 3. And when we plug number 3, we get a positive solution, which is 4, which is 5. So since one value is negative and the other value is positive, there is a sign change. According of the intermediate value theorem, this means there is a value c between 1 and 3, such that the of this c is equal 0. In fact, we can calculate it directly because of 2 equal 2 power of 2 minus 4, it's equal 0. So the root is c equal to. So now we came to the conclusion. So in conclusion, calculus is not just a subject we study in textbooks. It is a powerful tool that helps us understand and shape the world around us. Throughout this presentation, we explored how derivatives play a major role in economic analysis, allowing us to evaluate profit, cost, and revenue with precision. The concept of average revenue and marginal revenue are essential for businesses that want to make smarter financial decisions and grow effectively. We also looked at the intermediate value theorem, which shows us that mathematics can guarantee the existence of solutions under specific conditions. This simple yet profound idea is widely used in real life problem solving, from engineering to programming to scientific modeling. So thank you very much for watching me, and I hope you enjoyed my presentation. Wassalamu alaikum warahmatullah.